Hi, Rashid here. Today we will look into a flow example. Okay, I have a tickle file here that I used, um, and just to show you how it's very simple flow. Just to show you how a normal flow works. But this is a simple flow. My design is simple. I don't need to add so many things. But these are, in my opinion, the key things. Flows can be very complicated in bigger companies, but if you go inside where flows have a lot of code is in terms of making them generic for a lot of block needs, a lot of user needs. But under the hood, the commands are very few simple ones. Okay, so what do you want to do? What I have in my tickle file. At the top, before you start into routing, first of all, I commented it out, but I think it's good to put that. This is going to give you, okay, for example, certain ports are blocked, so that pins are blocked, they just can't be routed. This command is going to give you some information about that. But before you do the routing, what do you need? Think about it. Okay, of course you need to have a net list, standard cells there or macros there. They're all linked. I mean, they are able to get their layout views. You open a design. Before this, what was the stage we ran? CTS, right? So basically, you want to check first of all if every cell is placed. Even a CTS cells, even non-CTS cells, all of them have a legal location or not. That's one thing. Second thing is you have done a CTS on it or not. You should have at this stage a CTS, clock tree synthesis, done. As part of clock tree synthesis, you also want to make sure your clocks are routed. This routing stage is not going to route clock nets. Clock nets should already be routed in this database. So that is the other thing you want to check. Okay, placement, legal placement, CTS done, CTS routes are done. One other thing, the CTS routes need to have a don't touch on them because you don't want to touch your clock tree during this stage. This is only for signal routing. Clear that? Okay, so you should have some code here, whether check routability or some other ways, check legality or report CTS or something like that here at this stage. So that is a checking. I always, in every flow, I had a pre-check done. So that you need to have a pre-check here. This is the other thing, important thing to understand this. Connect PGNet or whatever tool you're using, should have something like this. Okay, so if you look at a netlist has cells instantiated like this. A netlist is a logical connection. It doesn't mention power. It doesn't mention that, okay, an actual inverter has actually VDD and VSS. So we now most of the time talk about timing and we just say there's the input and output. But there are always VDD and VSS on every cell. It's just in the logical timing picture, they don't come in, they're not there. Okay, but they are there, especially when during placements of CTS, you are pulling the layout views of the standard cells. Then layout views that as I showed you in the previous video, on a standard cell, when you show the pins, you see VSS and VDD there. So VDD, VSS are there. So they are there. They're typically called, they're not logical pin, but they're physical pin. So even when you do get pin on a cell, by default, tool might not return the VSS VDD. You need to use a switch dash physical with that. Then you get the VDD VSS. Okay, here is the connect PG net command does. So you have all these VDD VSS, and this design was not with the power grid on it, but I told you a separate video how you can create a power grid, and I used this command actually there even at that time. Here I'm just doing it just in case. Actually, it should be in the design already, the synthesis, and tool should maintain it, but I guess I was just making sure. So this pin VDD, I create at the top level my terminals or my all those. Remember the power grid that I had? So I need to logically even when I connect this physically, all different ring, then remember what else was a mesh, then comes the sensor rail, and eventually I through via connect these metal pins to the grid. That is all done, but logically, just like I'm saying, okay, logically A, how to say that? For example, O of this is connected to A of this, so I need to connect them together. You need to tell the tool logically as well. Even though you connect it physically, you haven't told the tool about the logical connection. The netlist doesn't have that logical connection. So connect PG net is your logical connection. You telling the tool, I have created a top level ports or terminals at top level, and I will assign different metals to them, and logically connect this one to all the VDD pins of every cell, which are on the same voltage, of course. Similarly, VSS needs to be connected to all the VSS pins, and that logical connection is important. So I think I'm just making sure. And what you see, the get pins, yeah, this is example. Physical contacts, I'd put a star there on all the cells. All the cells throughout your design, their VDD VSS will be connected to this power net and this ground net. Understood? Okay, that is done. Another setting that we need to do is further routing. What metal layers at the SoC level or in my physical design level on top of standard cell I'm going to use for signal routing. So I had a variable for this one, and I'm just passing them to this command. So, and later on I will check whether my routing is really using these one or not. This is in case you want to limit. You don't want to give very top 2-3 layers to them because you have them for something else. You can do that. Or maybe you're doing at a block level, your design eventually will be an IP used inside another SoC. You can also limit to certain other layers, and then so that the SoC level they can route on top of your IP on certain metal layers because you're not using them. But if you are using certain metal, the SoC at the top level will not be able to route above your IP. So selection of this can be important in the context of your projects or design. Then I'm using a mega command. You can use non-mega commands too. I think just a router, detail route type of thing. But I'm just using mega command. These days, these mega commands work pretty well. You can again, I believe I forgot completely. Was there from initial to something, but I just in one go use all of it. Again, my design is smaller, simple. Doesn't matter that much, but if your design is complex, bigger, you want to optimize every little bit because every step can create hours on runtime for you. So be aware of that. So okay, once that is done, I get no errors, everything goes well. Check routes. This command can check some stats on your general routing and maybe highlight some issues. Every tool will have something like that. And then after that, I go into reporting. Okay, now some of the reporting is pretty common across all. You see, I always report QR, report all the timing violators, then power. Then these are the two special reports on the routing, and those are the ones I'm gonna cover in the next video. Okay, so that's it for now. See you next time.